I'm Eunice Jen, and I'm excited to talk to you about our work on Tisane, authoring statistical models via formal reasoning from conceptual and data relationships. Consider this scenario. We have two health researchers who are interested in answering this research question. How does exercise affect weight loss? They collect data from 386 adults who are part of 40 different exercise groups. They randomly assign each group to one of two conditions, an experimental exercise regimen condition and a control condition. In addition, the researchers collect data about motivation, pounds lost, and their ages. Once they've collected this data, how should they go about analyzing it? When thinking about their data analysis, the researchers might ask themselves a series of questions, such as, which independent variables should we include? Condition, motivation, both, maybe something else? Should they include interaction effects? Are interaction effects important to their research question? Are they conceptually founded in their domain knowledge? How do they go about accounting for grouping or for the fact that groups of individuals were assigned to one of the two conditions, not the individuals themselves? What type of linear model should they use should they decide to use a linear model, maybe based on prior work or prior experience? Should they use a linear regression model, a mixed effects model? The key challenge here is that to author an accurate statistical analysis, end users must identify and align relevant knowledge about the domain, how the data were collected, and statistical methods. This process requires deep domain and statistical expertise, which may not always be available or possible for analysts, including many of us here as researchers. To address this issue, we developed Tisane. Tisane is a mixed initiative system that enables users to express and leverage their existing knowledge about their domain and data. Under the hood, it derives a space of possible models that align all three concerns and engages end users in a disambiguation loop to narrow the space to a final output model. We call this end-to-end process interactive compilation. So for the remainder of the talk, I'm excited to dive into each component with you. And in the spirit of Tisane, another name for herbal teas, let's start brewing up a Tisane program together. So once we've imported Tisane as a library, we can start by specifying the experimental units in our study design. In this case, it would be adult and group. Internally, Tisane then represents these two experimental units as nodes in a graph. Once we specify the experimental units, we can specify a set of measures that each unit contributes. So motivation, pounds lost, and age for adults, and condition for group. In the internal graph representation, each of these variables is a node, and there's specific edges from each unit, adult and group, to the measures. We can now then specify that adults are nested within groups, which introduces another edge from adult to group, which is specially typed for a nesting relationship. And then we can start specifying our conceptual relationships, such as the fact that we hypothesize that condition causes pounds lost, and that motivation and pounds lost are associated with one another, that age is associated with pounds lost, and that age is associated with motivation. The key difference between associations and causes relationships here is that causes are unidirectional, whereas associations are bidirectional. With these variables and their stated relationships, we can then specify a study design. Here we specify a dependent variable of pounds lost and independent variables of condition and motivation. We can then use the study design to query Tisane to infer a statistical model. Although Tisane can generate a space of models based on solely these relationships and the variables, there are a number of specific questions that have to do with maybe how the data will look like, and important questions about the researchers' end goals that need additional user input. To elicit this additional input, Tisane engages users in a disambiguation process. So here we see the same program being executed in a Jupyter Notebook, and this disambiguation process occurs inside of the Tisane GUI. So we see Tisane suggesting random effects and automatically inferring maximal random effects and asking end users for additional input to specify the final output model. It then generates code for this model and for visualizing that model, which we can then directly import and execute to see the results of that model, as well as a visualization for inspecting the model's fit. The final model that Tisane enables end users to author avoids common statistical mistakes documented in the statistical literature. Tisane focuses end users on authoring conceptually founded and justifiable models, and automatically infers maximal random effects that allow for generalizability. In addition to the code to fit and visualize the statistical model, Tisane outputs a log of interactions with the Tisane GUI for reproducibility. Tisane's interactive compilation process introduces a new programming and interaction model, and we were really interested to see how this new programming and interaction model affects real-world analyses. To assess this, we conducted case studies with 3 researchers, one in psychology, one in HCI, and another in health policy. So here I'll highlight a few key takeaways from our case studies. First, we found that Tisane filled in the statistical knowledge and programming gaps for researchers. In other words, Tisane bridged the gulf of execution for researchers in authoring analyses that addressed their goals. Tisane even helped the HCI researcher catch a bug in their analysis prior to submitting their paper to CHI. One way Tisane facilitated that was by focusing researchers on their domain knowledge and study designs. Tisane made researchers aware of their implicit assumptions and their knowledge about their domain and study design that they usually just keep in their head. When asked about future possibilities for using Tisane, the researchers expressed that they really understood Tisane's language constructs, but they wished it would adapt to some more of the specialized or customized language in their domains. In addition, the health policy researcher expressed a really interesting idea of adapting Tisane to not just generate a single final model, but a space of possible models to explore. So in future work, we're really excited to explore some of these questions around domain specialization, as well as more intelligent defaults. All in all, our observations and the researchers' feedback in our case studies suggest that Tisane is helpful for streamlining specifications for simpler statistical models and for guiding the prototyping of more complex models. With that, I want to emphasize that Tisane is open source, and there is a Python implementation of Tisane as well as an R implementation. Thank you so much for your attention.